Let us study about a very important and a basic law in electricity called as Ohm's law. Ohm's law was discovered by a scientist called as Georg Simon Ohm. It was discovered in 1827. It was discovered in 1826 and it was published in 1827. The picture here is the picture of Simon Ohm. So let us define as to what is Ohm's law. It states that with temperature and other physical parameters of a conductor remaining constant, that is, for a given conductor, its temperature and other physical parameters should remain constant. In that case, the current passing through the conductor is directly proportional to the potential difference applied across the ends of the conductor. If we write this mathematically, now what it would mean is that it says the current through a conductor is directly proportional to the difference in voltage across its ends. For example, if we take a conductor where we have 2 points, let the potential at this point be called as V1. At this point, let it be called as V2. If we assume that V1 is more than V2, then current will flow from this end to this end. Let us call that current as I. Now this current is directly proportional to the difference in voltage. That is what is the law telling us. If we call that difference as V, this is what is the law. But for some reasons, books write it the other way around. Even though the law is defined saying that the current passing through the conductor is directly proportional to the potential difference applied across the ends of the conductor, but what books write it as V is directly proportional to current I. Now this form and the form what is stated, these two are not correct physically, but these two are correct mathematically. Now there are many instances where a law is defined in one form and a law is written in another form. We can recall two more examples of same kind. One example is about Newton's second law of motion. It says that the rate of change of momentum is directly proportional to the applied force and the change takes place in the direction of the force itself, but it is written as F is directly proportional to dp by dt, but defined in other way around. One example is, we saw that the voltage on a conductor is directly proportional to the charge on the conductor, but we write this as Q proportional to V. So there are instances where a given statement or given law is stated in one form but written in another form. It becomes clear as to why we write that way. For now, we will write is the law as given in this form only, which is what books will write. So we'll start writing it as V is proportional to I. Now here we need to bring in a constant, and that constant is called as R. So we write V is equal to I into R, where this R is called as the constant of proportionality mathematically, but physically this R is called as resistance of the device. Now any device for a matter will offer some opposition that is called as resistance. The amount of resistance will vary depending on the material as well as length and area of cross section, but any device or most device will offer resistance. That's called as R. Now if we rewrite this, let us take a case where R is equal to 5 unit. We'll define what is the unit for R in a minute. Let us take R as 5 units for now. Which means here what we get is we get V is equal to 5 into I. If you rewrite this, if you write the law what we learned earlier, that is the law as given by Ohm, there we learned that I is proportional to V. Now here we can write this I is equal to some constant into V, some constant to V. Now compare this and compare this. If we bring this 5 down, then we get I is equal to V by 5. But 1 by 5 is 0.2, so it becomes 0.2 into V. So from this alone, we can say I is proportional to V, which means starting from here, we can arrive at this form, and these two are correct mathematically, but these are not correct physically. So remember this point also as to how it is written. Now we defined what the constant of proportionality what, and that is called as resistance. Its symbol is drawn like this, a straight line with few lines of this kind represents a resistant. Here an example of a resistor is given. Resistance is a property and resistor is the device, and resistance is its property. So here a device called as resistor is shown. There are many forms of resistor, and what is shown here is the form which is most commonly used in lab. To define resistance, we can say it is a measure of opposition to the flow of steady current. So whenever current flows in a material, the opposition which the material offers is called as resistance. Now here, to understand this, if we look at a conductor of some form, then there is something called as free electrons. Now these free electrons will start to move in the conductor. When the electrons move in the conductor, let us take one electron and track its motion. The electron moves in the conductor, there will be atoms at every point. Just put these circles as atoms. So red ones are the atoms, they're quite big. I'm just drawing a 2D view of the material. It's called as atoms. If an electron collides here, it may rebound. So it may start to go like this, it may again collide here. It may collide like this. It will have a random collision in all the points. It may even go back also. So it has random collisions. It is not free to move. So this opposition offered by the device is called as resistance. Mathematically, we can define R as V by I. So it is a ratio of V by I, and for a given material, for a given length and for a given area, it is a constant. Keep in mind that we are not defining R from here because R is not defined from here. Rather, we can write R also as this form only. Now if you look at its SI unit, it will be volt per ampere, and this has got a special name to it, and this is called as Ohm, which is named after the scientist. Its symbol is something like this. It's a Greek alphabet, and this represents Ohm. And solve and say this, verify its dimensional formula, that will be equal to m L square T power minus 3 and A power minus 2. So this would be its dimensional formula.